Hey, hello everyone. This is a PowerPoint just to show you how to calculate bond energies. The first thing we need to talk about when talking about bond energies is the making and breaking of chemical bonds. So as it says here, most chemicals will break up or decompose if they are heated strongly enough. So this means that energy is needed to break chemical bonds, which is an endothermic process, as energy needs to be put in to the reaction in order to break a bond. Okay, think about it like if you're trying to break a pencil, for example, and you're trying to break the pencil, you need to put in energy to try and break that pencil. It's the same thing for a chemical bond. Okay, so for example here, this is the compound. When you put energy in, energy is absorbed by it, and then the compound breaks off into two. Okay, so that's an endothermic process, and that's the breaking of chemical bonds. Making chemical bonds is essentially the opposite. So because bond breaking is endothermic, bond making must be therefore exothermic. So that means energy is released when the chemical bonds are made. So when two atoms will come together to join up, that means energy is going to be released, and therefore they will create a bond such as this. If you would like to take notes on this, you can pause the video at this point. Okay, so the next thing we need to talk about is calculating delta H using bond energies. Delta H is just another name for energy change. So we're talking about calculating energy changes using bond energies. Okay, so step one, first thing you need to do is to determine the number and type of bonds broken and formed from the balanced equation. We'll have a look at some examples in a moment. So this may require you to draw the molecules to identify how many of each bond type are present. So it's a good idea for you to draw out the molecules to identify and see clearly how many of each bond type are present. Step 2, multiply the number of bonds by the bond energy given in the table to determine the energy change. So there will be a data table that's given to you, which again I'll show you to you in a moment, and from that you will calculate how the bond energy itself. And then step 3, plug the values into this formula to calculate the delta H of the overall reaction. And the formula is this. So this means the sum of, you must see this in maths, sum of the bonds broken, okay, sum of the energy of the bonds broken minus sum of energy of the bonds formed. Okay, so as I say, we'll have a look at an example in a moment. Okay, first I'm just going to show you how to calculate the delta H of bonds broken or bonds formed. So here's an example. The energy to break a bond in a compound can be used to work out the overall energy changes. For example, ethane. Ethane has this structure: 2 carbons and 6 hydrogens. Okay, and from this you can see that it has 6 CH bonds. By CH bonds, what I mean is there is a line in between a C and a H 6 times. So here's 1, here's 2, here's 3, 4, 5, and 6. Okay, and it also has 1 C-C bond. So 1 carbon-carbon single bond here. Now I was talking about the data table. This is the kind of data table that you get given to you. It will have the bond in there and the average bond enthalpy. The bond length, that's more for A-level, so this is also an A-level topic, so that may come up in A-level. But the main for GCSE, you have to look at is these two columns here. So for example, the bond energy for a carbon-carbon bond is plus 347. So in order to break a carbon-carbon single bond, you will need to input 347 kilojoules per mole, which is a unit, of energy to break the carbon-carbon bond. If it's a carbon-carbon double bond, it will be 612, etc. Okay, so let's have a look at what the total energy is to break the bonds in this ethane molecule. So from the bond enthalpies from the table here, and using the displayed formula for ethane, structural formula, it's a good idea, like I said, to draw it out, because then you can clearly see how many bonds there are for each one, and it makes it a lot easier to calculate. So the CH bond from the table here, we can say is 413. Okay, so 413, that's what I've written up there. Remember we said there are 6 of these, so 1, 2, 3, 4, 5, 6. Okay, so we'd have to do 6 times 413. So 6 times the amount of CH, so 6 times 413, that gives me 2,478. Okay, so that's what we've got so far. But then remember we said there's a carbon-carbon single bond as well, so then that's just 347, so again from the table here. So that's 1 times 347 because there's only one type of this bond. Then all you need to do at the end is add these two values together. Okay, so the total amount of bonds broken, so the sum of the bonds broken, is 2,478 plus 347, which gives you 2,825, and again, kilojoules per mole. Do not forget the units. Okay. So again, if you want to pause the video, have a look through this, you can pause it at this point. So this is the energy required to break the bonds in ethane. So altogether, in order to break all of these bonds in ethane, to make these 3 atoms, you will need to input 2,825 kilojoules per mole to break all the bonds. So now we're going to look at an example question of putting it all together. Okay, so slightly different data table here. So as I say, these are the bond energies that you'll need, and these are the bonds. We're going to look at specific examples. I've already picked one out. So this is this equation here. So methane plus oxygen gives you carbon dioxide and water. Okay, it's a simple combustion reaction. We'll have a look at this example. So as I said, the first thing I would do is draw this out. Okay, so I'll draw this out. So methane looks like this with 1 carbon and 4 hydrogens. 1, 2, 3, 4. You've got 2 oxygens. Okay, 2 lots of oxygens here. So 1, 2. That's the O2 part. And then you've got the 2, which comes into it as well. And then CO2 has 1 carbon, 2 oxygens. Again, these are double bonds. And then water here has oxygen and a hydrogen bonded together, another oxygen and hydrogen. Okay, but then there's 2 lots of that as well. So therefore, there's a 2 in front of it. Okay, so as mentioned before, this is the formula. So the amount of the sum of bonds broken minus the sum of the bonds formed. Okay, also can be written as the sum of the reactants minus sum of the products, whichever one's easier for you to remember. Okay, sum of reactants take away the sum of the products, or sum of the bonds broken take away the sum of the bonds formed. Okay, so now the next thing is we look at the data table and we need to input our values and try and figure out what the actual sum of the bonds broken is, what the actual sum of the bonds formed is. So let's have a look. CH bond. CH bond is here, again 413. So the values usually stay the same. So CH bond is 413, and there are 4 lots of those. Okay, so 4 times 413 will be the first part. And the next part is oxygen. Double bonded oxygen is here. So oxygen bonded to another oxygen, double bond is 498. But because there are 2 lots of it, because there's a 2 in front of it, you have to times everything, you have to times it by 2. So you've got 4 times 413 from the methane and 2 times 498 from the oxygen. So that's the total of the reactants, or that's the total of the bonds broken. Okay. Then on the bonds formed side, you've got carbon, double bond to oxygen, you've got 1, and then you've got the second carbon to double bond oxygen here. So there are 2 types of that bond, and this is 805. So you have to do 2 times 805 for that one. And then for the water, you've got OH. OH bond is 464. So again, there's 1 and 2 here. But obviously, there's 2 lots of it there. 2 lots of it. So you'd have to do 4 times 464. Okay. So again, I'll just go through that again. So there's OH1 here. There's OH second one here. But there are 2 lots of this molecule. So therefore, essentially, you will draw it out again. OH here and an OH here. So altogether, there will be 4. Okay. Right. And then all you have to do is put these numbers into the calculator. On this side, you get 2,648. And obviously remember the minus sign in the middle. On this side, you would get 3,466. And then obviously you just take those away from each other, which will give you minus 818. Again, don't forget the units, kilojoules per mole. Okay, and also, as it's a minus sign here, this tells us that it's an exothermic reaction. So therefore, more energy needs to be more energy is given out in this reaction, okay, when during the combustion reaction, which makes sense because we know that during combustion you're burning fuels, you're burning gas, which releases energy. Okay, and then finally, this is just at the bottom to summarize. So there are 4 CH bonds, 2 O double bond O bonds, 2 C double bond O bonds, and 4 OH bonds. Again, the numbers are just in there, and then that's the final answer here. So again, if you'd like to pause and take this in, now will be a good time to do that. Here are some, I'm going to give you some practice questions, so I'll leave this slide on there in case you want to, this is the data table once again. Practice questions are here. We just did question C already. That's one I showed you as the example. But here are some questions, so you can pause it at this point to have a go and attempt some of these questions. Okay, and then once you're happy, once you're done, once you've paused the video, there are some answers on the following 2 slides. So next slide again, just check your answers. Here again, this is the one that we've done already. So don't worry about that one. So I'm gonna, again, you can pause it at this point to see if you've drawn the structures correctly. And then finally, this is just a table again with the answers. Okay, again, we've done this one already. Usually these questions can be up to 6 marks, so it's a skill that is well worth knowing how to do. And as I said, if you would like to pursue chemistry at A level, it's also good practice for you to get it in early now. Okay, so I hope this video was very useful for you, and hopefully now you know how to calculate bond energies. Thank you.